Hey guys, it's Luke, and welcome to another video here on my channel. And today we're going to have a look at computer properties in Swift. If you don't really know what Swift is, it's a programming language. I covered it on my old channel, and here on this channel, as you probably know, I'm actually just going to do things that I really care about. So there's not going to be a lot of videos. There aren't going to be a lot of videos, but well, I just try to show you some really sneaky things that you can do to improve your programming. So today that's going to be Swift, even though Swift is not one of my main programming languages anymore. The ones that I'm really interested in are Go and Rust, but Swift is still on my favorite list. So yeah, computer properties is today's topic, and we're gonna actually head in right away. If you want to code in Swift 4, you can do that. Swift 3, it should work with any language of Swift, I think, any version. I'm not really certain about it, but I think it should work. So, we're just going to have a playground. We don't need a project, and we're just going to call it computer properties. And we're also going to use extensions today in order to show you that. So I have my playground here. I am actually going to, give me a second please, I'm going to actually scale up the font size so you can read it a lot better. I mean, there is presentation, but I don't think you need it that big. That's probably gonna do it as well. So we're just gonna import Foundation. We don't need UIKit. We're not gonna do anything with interfaces here. And sorry for the microphone quality. I actually have a better microphone, but I actually have no space right now because of school stuff. The school year started 3 weeks ago, basically, and it's been really stressful. And yeah, so today's day, which is Saturday, I just want to use in order to actually do some programming after a while to just have some fun and relax for once that I do not have a lot of stuff to do. Alright, so we're actually going to create something that I want to use in a project, for instance, that is actually practical. In my opinion, that would be you have a string and you want to see whether or not it's alphabetic, if it has characters that are not alphabetic. That means anything not A to Z or any character within alphabetic range, like the German characters that you may know. Those will be alphabetic as well, but everything else, like an exclamation mark or a question mark, are not going to be alphabetic, and then you want to check if it is or not. That's probably useful, for instance, for an input field in your app. Alright, so let's actually do that. So the first thing that I want to create is, it makes a lot of sense to do a function for this, right? And you pass in your word and you should be good to go. So we have our function keyword. And yeah, so by the way, if you have heard of computer properties, you can actually skip a little. I'm just going to create a function right now to have a little transition to computer properties. It will make much more sense to you if you first do something and then see its use case while you do it, or while you are doing it. So yeah, function, and we're just gonna call it plain is alphabetic. And what it will take is something that we'll talk about in a second, and what it will return is a bool, because it asks is. And there you go. So let's just have a bool, let's just return true for now, so it actually doesn't complain. So there you are. And we need a word or some input to check whether or not it is, or which word is or not. Maybe that wasn't such great of a sentence structure just now. So we're gonna say word or W, but word probably does it better. And we're just gonna say string. And yeah, so string, we have our string, and now in order to have our sequence or alphabet, we have to actually create it, and it's really simple to do so. I just call it sequence, or you can call it alphabet or something like that. And then what you do is say character, and now you can say A to, it's a range. If you don't know ranges, look them up. they're really useful. And there you go. So now you have a range, and it will probably tell you, yeah, you've never used it, so you can actually just, you do not have to name it. So character A to Z, and we'll generate your whole. Well, actually, it won't generate the letters. It will just say from here to there. All right, that's really useful. And now what we can do is we have our word here, and we want to go through its characters. You do so by saying words.characters, and then for each. If you don't know for each, that's okay, because we are actually going to be using for in a sense. I actually didn't think about it if people know about it or not. Some may not. So for, and we say word, or actually character in characters. So now it goes through this. This is like a list. If you don't know too much of programming, characters is an array, but I'm just going to assume you know it. It's a list or character array of single characters of that word. So if it's, for instance, hello, H, E, double L, and O. While the L's are not together, they're separate. Sorry, that wasn't too clear. And now we're going to actually compare it. And that's really easy. To see whether or not it's in the sequence, we can do so by saying sequence.contains. And then you see it takes an element of the type character. Now, the issue is you don't know how to use, in which sense the user is going to type in a word. Maybe he's really a chaotic person and is going to write it like this. And, well, that might be an issue. I'm actually not sure how it generates this list. We can actually check on it right now by saying just char. And if the sequence contains the character, it will actually simply return true. But in programming, it's really a good convention to check whether or not if it's false. So if we have a character that is not in the alphabet, we have false, and it will never go in here. So what we can do is simply put an exclamation mark in front of it, and it will swap around true and false. So what is true becomes false, and what is false becomes true. Because if you probably know that, but if you write, for instance, 5x is smaller than 5, if it actually is, so 3 smaller than 5, that's true, and then this just turns into true. Because if only executes what's true. So now, if the character is not in here, it's false, but through this, it turns true. And here you go. Now we can return that it's not. It's false. And we're good. We could simply return. You can simply return it here, but then it would leave the whole flow. It will leave the function. And we do not need an else because we only want to see if that ever happens. So we hope it won't happen. So that's why we return true. But if you have a return keyword, it will actually leave the whole function if you didn't know. So there you go. Even if it's not at the end of the function. You can now check on it if that works. If I say hello, I'm not quite sure if it just goes lowercase or not. False. Okay, so it doesn't work the way I wanted it to work. There is a way to change that. You can just say lowercase to a char, and sadly it doesn't work. So what we can do instead is we can turn it into a string like so, and say lowercase because we have a lowercase range here. Now that is not a character, and we can turn it into a character the same way we turned it into a string. That looks a little messy, but now you see it's true. And if I put an exclamation mark here, it becomes false. Now it will be cool if we did not have to actually put in that word as an argument, or that we do not have, that it's not obligatory to have a parameter here at the declaration, and that's what computed properties are for. So it would be really nice if we could say hello and then is alphabetic and then that. But why those parentheses? You do not pass anything in, and that would do as well. And that's what computed properties are for. And we're going to use them right now. So we know we're only going to do strings here. So we can say extension and string and extend the string with a new function, or in this case, computed property. And that's really easy. It's basically a variable, and we say is alphabetic, and then what type it has, and that's a bool. So basically, it's just another property of your type, and it's a bool. But within, you can do all the computation that you want to do, and that's basically our function right here. So we can take its content, remove it, and paste it into here. It won't exactly work this way. If we click here, what does it say? Here, word. It doesn't know word. That makes sense because we do not have any parameters, or in a sense when we put in the input, we don't have arguments. So what we can do is self, and self is the string itself, and that is really nice code. And now what we can do is simply go and say, for instance, hello. We have a string, and we can say is alphabetic, or for instance, name, or actually not name. Well, what can we do? Yeah, let's say do name. And now we can, for instance, say Luke. I'm sort of a narcissist right now, using my own name. And we can say if name is alphabetic, and again, let's just turn it around. If it's not, let's say print that's not a name. Well, it is a name, so if we do that, that's not a name. Great, so now you know what computed properties are, and you probably have a really nice example now. I hope this was useful to you. If you have any recommendations for what you'd like to know, let me know. Or if you see any way I can improve my tutorials, if anything was confusing, if I talk too fast, if I should not assume too much of your programming skills, let me know. I'm always open to these things, and yeah. Thanks for watching, and I hope I'll see you really soon. Bye.